Hey everyone, welcome to UMCP Podcast number 4 or 5. Not totally sure. Today we got Andrea here. Welcome, Andrea.
Hello. Yeah, thanks for having me, Vince and Abram.
No
It's
problem.
honored to be your guest today.
We're excited to
Good.
have you. Why don't you tell us a little bit about the place you're coming from, the IEEE?
Yeah, absolutely. So we'd say that we will actually call this Bison's Programming Team, or BPT for short. You could say that this is a program under the UMIEEE. So UMIEEE stands for University of Manitoba Institutes of Electrical Engineers. And let's say they develop, I am also part of those, so we can say we develop a program for students so that they can have some formal competitive programming training. And I think it started out as something simple, like, oh, we all wanted to join a contest under the IEEE, and it's called the IEEE Extreme. But as we moved forward, we started to make some formal training sessions. We had a faculty instructor who is a very awesome person. He's a engineering professor, and he's just the best. And if you guys have any questions, just ask me.
Awesome.
No,
Yeah.
it sounds cool.
So this is our first podcast episode for the new year. So welcome all the students to the winter term. Welcome back if you're returning, or welcome to U of M if you're a new student. We are the competitive programming club, so we're more of like a social meeting place for people that are interested in competitive programming. So whether that be at a collegiate level, as a hobby, some upcoming contest to keep on your radar is ICPC. This is like the WrestleMania of programming competitions, the International Collegiate Programming Contest. So this is coming up late February. You can join with teams of up to 3 people. And that is something that we wanted to prepare a lot of people for with if you've seen our UMCP Open Contest. And as well as that, the Google hash code is coming up with, which is teams of up to 4, which is a couple days before ICPC.
Yeah, really excited.
Oh. Yeah, it is exciting. Very exciting. It was fun last year too.
Mm-hmm.
Oh,
Lots
yeah.
of fun. Did you participate, Andrea?
I didn't. So I haven't participated in any competitive programming contest until this year. So yeah, tell me about some of your experience.
Sure, yeah. Aaron, do you have a favorite problem that you did last year?
Oh, there's so many it's ICPC is sort of like, sometimes you run into something and you're just like, wow, I couldn't get this in a million years.
Yeah.
It's so shocking. Like, it definitely is interesting because there's intro problems, but there's also like super high level problems. Like there's some problems that, teams out of MIT are struggling on. So it's a pretty serious competition. And also, it's funny. We had a recording that was deleted, but what I was saying in that old recording was the ICPC is like a well-respected competition by like a lot of universities and careers. If you score well at ICPC, it's not like it's a huge deal, and you'll even have IBM, Amazon reaching out to work with you. So it's an important competition.
Yeah, I remember. So last year we participated. This was last year was our first year of competitive programming. I mean, me and Abram actually did like a high school competition in grade 12, but aside from that, we didn't do any in like first, second, third year, anything like that. Like we never even really heard of it or knew what it was. But last year was our first year at ICPC. And we managed to qualify at the North Central Regionals, and we went on to the North America Divisional Championships. So they broke up all the people that moved on into North, South, East, West. And then it was like the top 8 teams, I think, from there moved on. We didn't end up moving on, but we made it to that stage. And even just qualifying to that stage, I remember in the opening ceremony, the host...
That is a huge...
Yeah, it actually was a big deal because in the opening ceremony, the host was bringing up the sponsors, and it was Amazon, JetBrains, I think it was like the CIA, like the US intelligence security agency, and another company that I forget. but they were the sponsors, and he said, and these companies want me to mention that anyone at this stage, they want you to apply for an internship or for a job for something, because even just making it to this stage means like they want you, because competitive programming is something that's just so important and so like easily transferable to the real world, because it's you might see a question that's similar to an assignment that you would get in a coding class, but in a class you would say they want you to create a car program that can hold a car object and whatnot. In an assignment, you'd expect them to say, okay, the car is going to have these fields, it's going to have these functions, this is how it's going to be interacted with, so on and so on. In a competitive programming contest, all it would say, it would just say create a car object. That's it. Like, create a car class. It's going to have this input, and I want to see this in the end. You have to be the one to figure out how to do it, and that's what employers are looking for. They're looking for people that they can give a task to, and they'll be able to know how to figure out how to do that task.
Yeah, and that's why
thank you so much. That is amazing insight.
Yeah. No problem.
It's really the fact where you said that these program contests are not just for fun. Like, it's just a little leisure thing. It's serious, and it can potentially land you jobs. That's something new.
Yeah.
Yeah, totally.
Wow.
Absolutely. And the reason is these jobs, if you go to a job interview, they will ask you questions, the same types of questions you'll see in these competitions, and they won't give you hints or help, like you're on your own. So like you just said, it's not like you're doing an assignment and it says, okay, write a loop that does this, right? This program and this program. It's just a problem, and they just say, how would you solve this? And if you can't solve it, you're in trouble.
Yeah.
Like they're gonna not like that. So this is good practice for getting jobs, not just a fun hobby.
Sure.
So I think I did mention this before, that we have our UMCP Open Contest. So by the time the viewers are seeing this, the contest will be concluded. So I wanted to go over the solutions with everybody, or not really go over like specific code, but more discuss the problems and kind of discuss how you would solve it. So for the viewers that are watching, you may know there's two divisions. So there's the beginner division and the advanced division. So if you're a U of M student, the beginner division is targeted towards those who are beginner programmers. So all of the questions in here you should be able to solve with just knowledge from Comp 1010 and Comp 1020. We don't go beyond anything like that. There's no graphs, there's no trees, there's no advanced algorithms, anything like that. So the very first one is nice and simple. But the thing is, even though in competitive programming style, even though you might have the tools to do it with Comp 1010 and Comp 1020, that doesn't mean that they're all going to be necessarily easy. They still could require some thought to figure out. So the first one I wanted to look at is date night. This one's pretty simple. All you're doing is converting a date in the format like where the month is in words, so January, February, March, April, May, and then you're given the date as the number with a suffix, so either the th, the st, the nd, whatever it is, and then comma, space, the year. So this one, there's so many ways to solve something like this, but Abram, let me pass it off to you. How would you go about solving something like this?
Yeah, this question was mostly about helping people, get used to parsing an input, which basically means you're taking this input, you're reading it, and you're breaking the little pieces down and extracting the important part. I would personally create an array or something, and I would just have the words January, February, March, April, May, just so I know the month of the year it is, so I could transfer, once I read in that January text, I could convert it to the 01. And then obviously reading in 2014, you just output 2014. And one more thing I want to mention, one sort of maybe complicated part of this question would be, it says January 5th. How do you know if it's going to be 5th with a TH or 2nd with an ND or 1st with an ST? If you know how to use substrings in literally any programming language, then you can chop off those last few characters, which is pretty simple, and then you can make the output.
Yeah, so it's always given with the comma as well. So if you split it by space, you'll be given the month in words, then the date with like the extra letters and whatnot, and then the year is already there. So the date, all you have to do is that it's going to have 3 extra characters. It's going to have either th, st, or nd, and plus the comma. So all you have to do is, like you said, just break off those 3 extra characters, and now you have the date in numeric form. And then all it takes is, there's no elegant solution to converting the word January to the number 1. Like, you literally just have to kind of hard code that in there with whether you use a dictionary or a bunch of if statements, whatever you want to do to get January into being 01.
Totally. Yeah, you could use a switch if, or you could use I would probably make an array, to be honest.
Yeah, personally, I like a dictionary. I like using using the month name as keys. Sorry,
Andrew, what were you saying?
Yeah, which programming languages are you going to accept?
Right. Yeah. So I guess I forgot to mention that. So we wanted to make it as similar to ICPC as possible, because this is mainly meant to be preparation for that. So we accept Java, C, C++, Python, JavaScript, and Kotlin, because those are the ones accepted at ICPC. So for a question like this, I would definitely recommend Python or just another scripting language, because they have a lot of built-in stuff to deal with just parsing input. Usually when you see a parsing input type question, Python is usually a good bet.
Mm-hmm.
But yeah, totally. That's pretty much
Python is strong in competitive programming in general. If you're starting up and you don't know which language to use, and you know Python already, I would highly recommend Python.
Yeah. But the other side of that too is, if you're starting off, I wouldn't worry about learning a new language for competitive programming. I would stick to whatever you know the best, because when you're already using 99% of your brain trying to figure out a question, you don't want to have to commit another 50% of your brain to just the syntax of this new programming language you're trying to pick up. Do something that you already know by heart.
Yeah, you don't want to be opening up W3 School saying, how do I do a for loop in Python?
Geeks for Geeks is my go-to.
All right. We all got it.
How to initialize a variable in JavaScript. So now the next one was another pretty simple one, I'd say, in the area. The thing is about this is also, for competitive programming, you have to learn how to extract the problem from the instructions, because you'll always be given the problem as if it's a real world scenario. You're rarely given it in just straight up instructions. So in this one, it's talking about a friend named John. Me and Averin actually do have a friend named John. He's one of the staff in our club here at Supser, if you want to say hi to him. But
there is John. Yeah. Hello, John.
But in this one, he's saying that he is around your house and he wants to stop by, and you're saying, oh, you might be too far. I don't want you to drive so far. Maybe the weather's bad. There's a blizzard outside. We do live in Winnipeg. So what you're doing is you're given your own coordinates and John's coordinates, and you're trying to figure out if he's truly in the area. So what it's given is a maximum distance away from you where you would allow him to come to your house. Otherwise, you'd say, hey, you're too far. I don't want you driving that far. So all you're actually doing here is checking if the distance between the 2 points is less than or equal to the distance it gives you. So in the example here, you're given 0, 0 as your position and 4, 8 as John's position. So just by using Pythagorean's theorem, basically, to find the distance between 2 points in a 2D plane, is just you'd find 4 squared and 16 squared, and you'd get, I think it's 8 something, but yeah, it's definitely bigger than 1. So you can imagine this as if, here, I could actually bring up a little paint thing here for those watching. So you can imagine if this is 0, 0, and this is 4, 8, let's say way up here, if you're given a distance of 1, that means they can be anywhere in this circle, in the area of this circle. So now in the next scenario where you're given 4, 7 and 4, 8, all you have to do is just the same thing, is now the point that you're starting at is closer, and you see if it's within the area. In that case, you do. So this one is it's an example of where the instructions might be more complicated than the actual question itself. The instructions are talking about this whole scenario of your friend wanting to come visit you and all this stuff, but really all you're actually doing is just calculating the distance between 2 points.
Yeah, that's how computer science always is. If they would just ask find the distance between these 2 points, then you'd be done in a second. But same with I think we're going to see in these next few questions, a lot of them, if they were simplified to their core problem, you'd be done within a minute. But understanding the problem and seeing like, how do I actually do this with code? How do I solve this problem with code? That's most of it.
And the funny thing is too, you may think that like simplifying a problem, oh, it's so useless, why don't you just tell me what the actual problem is simplifying a problem is actually, if you've taken 3170 with advanced analysis of algorithms, simplifying a problem is actually a very important thing in computer science, of being able to break down more difficult problems into problems that you already know the answer to, with like, does P equal NP, like that type of stuff where you have simplification.
Totally.
So that is actually a very real thing in computer science, being able to simplify a problem.
Yep.
So yeah, let's go on to the next one. So pushing P. So this one actually has pretty complicated instructions, I would say, but I don't want to like take too long, like you're just explaining all of it. So maybe let's just explain it with the example. So
yeah,
basically,
the example is really what clarifies it.
Yeah. So basically, let's say there's a given amount of posts. So in this case, there's 11 posts because you're given k equals 10. So one thing to notice is you always have to be very precise about the instructions, because they will try to purposely mess you up. So and sometimes in these you're given some type of numbering, and sometimes it's from 1 to n, but in this case it's from 0 to n, which means you have n plus 1 posts. So in this one you have 11 posts, so they're all 0. So first you're pushing a weight of size 5 to k equals 10. So as you see, it increments in the second line here. It increments all the posts up to 10 by 5. But it's because it stops at the 10th post, it doesn't increment the 10th post. So now the next day they come back with a weight of post 2, and they go back to, weight 2, and they go back to that 10th post, and now they push it back to post 5. And so they increment the last one by 2 and all the ones in the weight of 5, and they stop at post 5 and don't increment it. And they just keep pushing it back and forth to the different posts. And at the very end of all these training days, you want to see which post has the highest number. And if there's a tie, the one closest to the left, or the one closest to 0. So that's pretty much all you're doing. So I want to pass that to you, Abram. How would you go about solving a question like this? So your input is you're given the total amount of posts, and then you're just given the days. You started at 0, and you're given the weight and the post you end at for that day, and then the post you end at for the next day, and the post you end at for the next day, and so on and so on.
So for this, I would start with an array where I'm keeping track of the count, I guess you could call it, for each post, and then as I with each day, I would
as you push P,
going to another. You could use a for loop to increment.
As you push P.
As you're pushing P, you would want to increment all the posts that you passed by P. Honestly, not too hard. You would do that in a loop for 10 times in this example. Yeah, this is not a bad one, to be honest. I think there's not much to it. And then at the end, you just have to sweep through the array to see which is the highest, and then output the index of the highest count.
And I think another thing to notice is this might be, well, I guess we'll see more examples of it, but this is an example of where you're reading in from standard input until you see the end of file character. So sometimes it'll tell you the exact amount of lines that are about to come, and so you could use just a normal for loop. But in this case, you don't know how many training days there are, how many lines we're going to give you, so you keep on reading until you see the end of file. So there's always going to be like a standard library function for that. So I know Java has like while ready. For Python, there's another type of while ready, or like has input. C++, you can just keep reading until you see that null terminal character. But this is one where we don't tell you how many lines there's going to be, so you have to know how to read input infinitely, basically, until the user stops it. So remainder. So this is the start of the 3-part series of the Cookie Monster working in a cookie factory. First of all, who decided to let the Cookie Monster work in a cookie factory?
Yeah. We only have one person to blame.
So this is another one where this one, honestly, the next 3 questions have like a whole lore and storyline to it, but the actual questions themselves are not very complicated. So just as a brief explanation of this one, the Cookie Monster, he works in a cookie factory, and he's given like an order. So that order is a number. So say he's given the number 6. That means I need to make a package of 6 cookies. So he has a cookie maker that he can type in whatever number he wants and it'll make that amount of cookies. But sometimes the cookie maker makes too many cookies. So it's guaranteed that it'll always at least make the amount you requested. So if you request 6, it'll at least make 6. But sometimes it makes more. So what Julia, who Cookie Monster's manager, does is to stop Cookie Monster from going crazy and just eating all the cookies he can. He's allowed to eat any leftover cookies. So if he puts in 6 and 7 comes out, he gets to eat 1 cookie. If he puts in 20 and 23 comes out, he gets to eat 3 cookies. If he puts in 4 and 13 comes out, he gets to eat 9 cookies. So Julia needs to make a report of how many cookies on any given day that the Cookie Monster has eaten. So you can do this by just checking the logs of the machine. So the machine gives out the logs for that day, and it tells you, it goes line by line, it tells you this amount was requested, this amount of cookies was made, this amount was requested, this amount of cookies was made. So you can use that knowledge to figure out how many cookies were eaten by the Cookie Monster. So this one's actually really, really simple, because all you do is you subtract the amount of cookies required from the amount of cookies that are actually made. So if 7 came out and you requested 6, 7 minus 6 is 1 extra cookie. If you request 100 and 105 come out, 105 minus 100 is 5. If you requested 10 cookies and 10 came out, 10 minus 10 is 0. So that's really all you do, and you just sum that up for this question.
Yeah, totally. This one's pretty simple. This part 1, I have a feeling like this is definitely a beginner question. Part 2 and 3 are a little bit trickier, but yeah.
Yeah, and now this one, though, it actually does give you how many lines of input there will be. So this is different from the last one where you had to do like a while ready type of loop. This one you could just do, so you could say the number of cases is the first line to convert it to an integer, and then you can just do a for loop because you know there's going to be exactly 8 lines coming next, or you can still do the while ready, like it's up to you. So the next one is where we start.
Yeah, and with this question too, you can keep on going. I'll just keep on talking. This question is funny because technically, even if you didn't know how many lines there'd be, it wouldn't actually impact it too much. Like you said, you just have to look for the end of the file, and because you're just tallying as you go line by line, this one's pretty simple.
Mm-hmm. So now the next one. So basically, you can pretty quickly imagine that a lot of cookies would be wasted. So if you say you requested 3 cookies and somehow 100 cookies came out, he would get to eat 97 cookies in that case, right? So that's a lot of waste. This is where we start to introduce a little more arithmetic that you might have seen in Comp 1010 or Comp 1020. So this one, Julia realizes that there's too much waste going on. She needs to cut that down somehow. And so she realizes, well, her original intention was to only eat the Cookie Monster, eat a couple extra ones anyways, but sometimes it spits out so many that it's hard to justify, and so many that it could actually fill multiple containers of the one requested. So now what she's going to do is she's going to say, if you request a certain amount and there's so many cookies that you could fill another box and another box and another box, what you're going to do is fill as many boxes of that size that you requested that you can, and then you can eat the leftover. This one, you can actually just very simply use the modulus operator. So if you're a beginner, you've never heard of modulus, the percent sign, basically what it does is it gives you the remainder of an integer division. So it tells you, so for example, if you had the number 10, you might know that 10 divided by 3 using integer division is just 3. If you used normal division with remainders, you would say, oh, it goes into 10 3 times because it can make 9 and there's 1 left over. So that's exactly what you're doing in this question, is that if you requested 3 cookies and 10 came out, you can see that, oh, I can make 3 packages of 3 and then 1 is left over. And you actually don't even care how many packages you're making. So you might think that you need to do like some type of for loop or while loop to like keep on making packages until you're left with an amount that is less than the number you requested. But the amount of packages that you're making is not asked for in this question. So all you have to do is take that number, modulus the requested number, and then get that remainder. And then you sum up all those remainders. So that's exactly what you do in this question. Finally, remaining remainders part 3. So this is this is where I really got creative. So the CEO Elmo
This one here is the same as the last one, except there's a limited number of each size bag. So you can see the additional input here. The number 3 at the top of the input, that tells you that they only have 3 of each size bag or packaging available. So what I think I understood it by is, like, if you look at the input where it says there's a packaging of size 4, but you need to fit 13 cookies in there. You can think to yourself, okay, so we can have 3 packs of 4, that's 12, and then 1 remainder can go to the Cookie Monster. So that's fine. That's just like the last question. But then you get to this next part. Again, you're using a packaging of size 4, and you have 5 more cookies. On the last question, you would have found the remainder. But with this question, it's more tricky because we've already used up all of the packaging of size 4, meaning all of these cookies are going to waste into the Cookie Monster's mouth.
Mm-hmm.
So you'll need to track the usage of your packaging, which is unlike the last one. Again, for me to solve this one, I would track the, you could use a dictionary, to be honest, to track how many left of each package size you have. You could use an array. Maybe a dictionary would be better for this one, though, because you don't really know what size bags you're going to run into.
Yeah, you're going to end up
then you don't want to have a static size array.
Yeah, if you had to, but you can, like, this is, that type of programming is done a lot in competitive programming. It's less practical, but if you know the constraints of the question, you could make an array of size 10 to the 9 and to keep track of every single possible like package size.
It would just be frowned upon, though.
Yeah, it would be frowned upon. But that type of stuff is employed in competitive programming. You would be surprised. Like, for example, there are questions where it'll ask you to find, like, say, prime numbers, or check if something is a prime number. And anyone would know that algorithm is always really slow. But sometimes it'll say the constraints are that the number I'm going to give you to check if it's a prime number only goes up to 10 million, let's say.
Right.
But you have like a decent amount of storage. Like, let's say you have 2 gigabytes of memory to solve that question. You will literally see people making an array of all the prime numbers from 1 to a million, and then they just do simple lookups of that array to make their to see if it's in that array to make it quicker. And that's just a log n solution.
Which is fine. I mean, if you, especially with competitive programming, you're using a lot of code. If you have the algorithm already written down, which gives you your list of 1 to 1 million, which are prime, which are not, then use it. You know, like a lot of the time, you don't need to worry about what the right programming practice is here. A lot of the time, the worst programming practice ends up
being
paying
the best
off in terms of how long it takes you.
Yeah, and this is very, very, like, dependent on where you work. Sometimes it would be frowned upon. Sometimes it might not, because sometimes that memory trade-off saves so much time. Like in that example for prime numbers, like the prime number to check those check if a number is a prime number, it takes like I forget how long, but it's actually really long. But if you can cut that down to log n just by storing a bunch of integers, and like if you needed to use that in a real workplace and you managed to bring it down from, like, let's say n squared down to log n, of course they're gonna say, you know what, yeah, that's a great program right there.
Yep.
So yeah, this one, I would say the biggest danger of this one is that the ones that have like such good stories, you tend to want to like get too into the story. Like, for example, if you see 4 or 5, you'd be so into that story, you'd think, oh, well, why would Cookie Monster even request 4 cookies? Like, he knows that there's no more packages of size 4. Like, why would he even request that? Wouldn't that just be 0? But the thing is, you have to always be very specific about the question instructions. The question instructions never said that he wouldn't request it. It does say that whenever you're given an order, he will request that. He will put it in. So you have to avoid trying to put in extra assumptions. You can never assume anything in these questions. You can only not assume things. You can only say, well, this wasn't explicitly given, so I'm going to assume that it isn't the case.
It's going to be exactly.
Or like it is a case, or whatever it is.
Yeah. And I was going to say, regarding getting into the lore, we had one member of UMCP who was so into this like Cookie Monster lore, they wrote their own part 4 as a fan fiction. And then they didn't even include the input-output example section of the question. It was just the story.
It's just a story about like Julia moving up to corporate and like Cookie Monster starting his own small plant. Like it was very interesting. Yeah.
Yeah.
Okay.
All right. Well, that's enough of that.
We are hearing it. Whoever is writing that fanfic, please.
Yes. Thank you for writing that.
So yeah, we can
You're
move on
amazing.
to the advanced category. So these ones, some of the I would say even like especially pushing P might be harder than some of these. It's just that a first year student might not be fully equipped to even understand how to solve these questions. But if you know a little bit deeper into computer science and computer science algorithms, these ones might be a little easier. Some of them are harder though. So Charlie bit my finger. So that you will see this a lot, that sometimes the titles have little hints of how to solve the question. So right there, bit my finger is like a pun, because you could say bit like biting, or bit as in numbers, like bits and bytes, right? So,
Right.
so in this one, basically you're given, let's just look at the input. You're given how a specified number of binary strings of the same length, and you want to know, so if it's a 1, the person or house at that position was bit on that night, and each line is its own night, and you want to know how many people were bit for every single night. So how might you do that with binary string? So this is actually really simple. If you have a lot of binary numbers, especially, it's like you don't even have to do much when they're all the same length, is you can just use the AND operation, because what the AND operation does is for any 2 binary strings, if it just spits out all the bits that are set in both strings. So if we just look at the top 2 binary strings here, what it would give you is 1 0 1 1 1 1 1 0 1 1, because those are the positions that are shared in both strings. So what we're looking at really is we want to know how many has a 1 in its position across every single string. So all you have to do is take the AND of every single string, then you'll be given a string which contains positions of the bits that were set every single night, and then you just count how many bits are there. And that's all you have to do. And in the second example, it gets a little more complicated. There's a lot more strings. It ends up being 0 in the end because I actually snuck in a string of all zeros. So this is
So sneaky.
This is really similar to if you're used to doing if statements with if, and or operations. It's the same and operation that's happening here. If you have true and true, it's going to be true. If you have true and false, it's going to be false. If you have false and false, it's going to be false. And you're trying to figure out how many bits are true and true all the nights. That's really all you're doing here.
Yeah, good question. I like that one.
This one, honestly, I would say is pretty complicated, especially to get an optimal solution. So this one we accidentally had a little typo that led to 2 interpretations of questions, and we will have accepted both interpretations. But as you'll see, it actually really doesn't change the question in the end. So this one, you're given flavors of cookies. So the Cookie Monster, this is actually a spin-off. We were so inspired by the Part 4 lore that we made a spin-off question of the remaining remainders, where Cookie Monster has instead moved out of his factory job. He has his own factory and his own storefront to sell the cookies as well. So he actually has a conversion shop as well. So what he does is if you give him a certain flavor of cookies, he'll convert it to another flavor. And the thing is, he takes payment, though. You can't just convert for free. So what he does is he has his rates posted on the door. They're only one way, and they're given to you. So for in this example, you can convert from chocolate chip to oatmeal raisin at a rate of 0.9, meaning if you gave him 10 chocolate chip cookies, using this rate, you'd end up with 9 chocolate chip cookies. So the question is, if I gave you a cookie I wanted to convert from, and a cookie I want to convert to, and the amount of cookies I have, what is the maximum amount of cookies I can end up with? Because if you'll notice, we're given oatmeal raisin and chocolate chunk. So you might say, oh, look, right there, oatmeal raisin, chocolate chunk, 0.3. So you end up with 30 cookies. But what you might not realize is you can go about this multiple ways. You could go from oatmeal raisin to red velvet for 0.92. So that's 100 times 0.92. And then you can go from red velvet to chocolate chunk for 0.99. So that'd be 100 times 0.92 times 0.99. And then you round to you always round down because Cookie Monster will just take the extra cookie, and you end up with 91 cookies. So this is an interesting question, and you might think, well, you could probably do this with like very simple algorithms, just for loops and lots of loops. But to check every single possible route from one cookie to another is going to take a really, really long time. But something you might notice if you have gotten into graphs, at least, and graphing algorithms, is that you can create a directed weighted graph here. So from chocolate, you could, if each cookie flavor is a node, then the edge from one node to another exists with a weight of the portion given. So for example, chocolate chip would have an edge connecting it from chocolate chip to oatmeal raisin with a weight of 0.9, and so on and so on. And all you actually need to do here is start at the given node and end at the given node. You just need to find the longest path or the heaviest path because they have weights. So to do that is actually, it's a fairly complicated algorithm. The execution isn't super complicated, but to really understand it, it's a subset of like the longest increasing subset question. Have you ever heard of that, Abram?
I haven't.
So that one is if you're say you're given an array of just random numbers, to find the longest subset of well, not even subset, or just like, I guess it technically is a subset, but not how you're thinking of numbers, so that they're always increasing. So it's like if you deleted other elements and you read it from left to right, it's always increasing. So for example, if you're given 10, 5, 6, 3, 8, 2, the longest one would be 5, 6, 8. Do you see what I'm saying with that?
Mm-hmm.
And yes, and it's the same thing as all you do is, so for this, there's something called a topological sorting for directed graphs. And what you do is you get a list of your nodes, and the leftmost node is pointed to by no other node. So it's the one doing all the pointing. And then as you go to the right, it's only pointed to, or only has it like an edge connecting it to itself, if the node where it's from is to the left of it in this list. So that's like your sorting of the nodes. And what you can do is you start at the leftmost one, or sorry, you would start at the node you want, and then you'd go to the right to the node you want to get to. And now the thing is, if that node that you want to get to appears to the left of the node in your topological sorting, that means it's not possible, because that means there's no way to get from that node to the other one because of the way you have it sorted, right? Because if it's to the left of it, that means it's not pointed to at all in no path from that node you're trying to start from. And then basically all you do is you start from that node and you go to the right to the node you want to end up at, and then you just check the paths that it has, and you'd use a greedy algorithm to always check the highest conversion rate. So in this one, so what I was saying with the issue was I accidentally had a typo where, so for the example I gave you, if you started at 10 chocolate chip cookies and you wanted oatmeal raisin, you'd end up with 9 using that conversion rate. But I accidentally said that that's how many cookies Cookie Monster eats. So that would mean that if I gave him 10 chocolate chip cookies and I said I want this 0.9 conversion rate, he would eat 9 cookies and you'd end up with 1. So to get the maximum cookies in the end, you'd end up needing to find the minimum conversion rate, because that's the minimum amount of cookies eaten by Cookie Monster. But you can see that that's actually just the exact same question, except when you get that topological sorting and you're using your greedy algorithm, instead of looking for the highest conversion rate, you look for the lowest conversion rate. But it's the exact same algorithm every other way. So that's why we said we'll accept either algorithm. But yeah, I think that's definitely one of our most complicated questions.
That is a tricky one. I'm interested to see who got that one.
Mm-hmm.
Maybe is it the next one? What's the next one? I'm pretty sure the one I think might be the hardest to implement is
it's the last
is
one.
That's
the last one.
Yeah, the movie theater. That one's tricky.
That's the last one.
Okay,
But yeah, but honestly, that graphing one, it reminds me of an ICPC question we had last year. It had another graphing algorithm, a directed graph, where you had to do a depth first search on it. And the thing is,
right,
this is
I
what
that.
And this is what I was talking with earlier about simplifications being so important, because This question is probably pretty difficult to understand, and especially if you're not thinking about graphs, I don't know how you'd even go about solving it without accidentally creating a graph, right?
Yeah,
But
totally. I agree. I think anyone solving it would be using graph algorithms without knowing it.
it's yeah, you would think, how could I ever come across knowing to go get in a topological sorting and find the longest path that way? Like, I'm converting cookies, how does that even make any sense? But if you're able to simplify this down to, oh, this is a directed graph question. So if I can make a directed graph, now I just need to find the longest path. Now I just need to know how to do the longest path, which is the algorithm I explained. You can do that very simply. Like this whole contest had 10 questions, and might be like, this whole thing might be something you'd see at the regionals. Like, you could imagine that you're sitting down to do the contest and you get these 10 questions. It would be something of similar, honestly, probably less of the easy ones, but it would be something like this.
Totally.
And you're given, say, 5 hours or however long it is. A lot of people never finish all the questions. Teams rarely finish all 10 questions, like very, very rarely. And I think last year at the regionals, the top team had 8. The second team had 7. The third and fourth had like tied for 6. I think if you answered 4 questions, you were immediately like top 20 or something like that. Like, you really jump up as the amount of questions. But the thing is, that doesn't mean it's not possible to solve these all in the 5 hours. It's very, very possible, but it requires you to see the simplification. You always have to, it's almost like a pattern recognition, problem solving thing to be able to do these quickly, is you have to recognize the problem at the heart of the problem. Like for this one, you have to recognize that it's a directed graph. And once you recognize that, you could solve this in 15, 20 minutes.
Totally. So let's get into the next questions.
Yeah, holiday gift giving. So this one's another simple one. So instead of a graph, we're working with a tree. So basically what happens is you're given someone's family tree. So you're given a family tree. And I mean, tree's right there in the name. It should be pretty obvious that you'll have to use a tree structure to do this. But honestly, you probably don't even have to. This one it's deceptively hard, because it's actually not that hard. It's very simple. So what you do is you're given someone's family tree, and you're given a name. So in this case, Jeremy. Oh, sorry. No, the input. Okay, right. Sorry, in the input, you're given Josh. So he's in the 3rd generation, and he's given a gift to Jenny, Jake, and Joanna. So we look at the list below them. So Joanna's off the table, Jenny's off the table, so he needs to give to Jeremy, Jessica, Jaden, and Jamie. That's all you have to do, right? So really all you have to do is you read in the tree, and you can just store it in a 2D array. It could be a ragged array. And then the first name you're given, you look for it in the array, and you just figure out which level it's at, or which line it's at, which generation it's at, whatever you want to do. And then the list that he has given gifts to, you want to take the symmetric difference of that and the total generation below him and find the symmetric difference so you can get the people he hasn't given a gift to. It's just like an opposite operation right there, is that if you have all the possible people to give gifts to, and you take away the people that you have given gifts to, you're left with the people that you need to still give a gift to. And that's really all you're doing in this question. Any thoughts on that? I wonder if
anyone, well, yeah, this is, it's funny. It definitely is deceiving. It's maybe the wordiest question of them all.
Mm-hmm.
So I'll be interested to see if anyone pursued this one. I feel like, for me at least, I know I'm more likely to go into questions that are brief. Maybe they're more complicated, but it definitely is more like inviting.
And that's the funny thing, is sometimes the shortest ones are the hardest ones.
Yep. Often.
There are times where the short one's like a nice easy one. Like one question we had was you're given 2 rectangle areas, and you have to figure out if like or 2 dimensions of 2 rectangles, figure out if one of them fits inside the other one or something like that.
Yeah.
It was super, super simple. But sometimes the short ones are really, really, really hard. And the ones that actually explain a lot are actually giving you so much information that it makes it easier and easier and easier. So it's a really interesting type of balance where you have to like be able to skim through a question and figure out like, oh, this actually is hard, or oh, this actually is easy. Yeah, let's go to the final
I agree with
one.
you.
This might be my favorite. I don't know, but this one is kind of complicated.
This is a good one. I actually think this might be my favorite too.
Okay, so imagine So you're Zacho the Marvel fan. His favorite movie is Spider-Man. His favorite superhero is Spider-Man. He wishes he was Spider-Man. Zacho 2K, he's one of our executives actually. And he's going to see Spider-Man No Way Home for the 8th time. Now that part of the question, completely irrelevant. But so he's going to try out a single row theater. So everyone's just seated in a single row for simplicity's sake. And basically what happens is you can imagine that as in a movie theater, you're probably not going to show up at the same time, right? And you would imagine that you want to get the best possible seat. So let's say like you're sitting in a movie theater. If there's a seat that isn't taken and it's like a better seat than yours and no one's sitting on it for the whole movie, you might think, well, I might as well move there, right? What's the harm if no one else is going to sit there? So in this case, everybody's having that same thought where I want to sit in the middle. There's just one row. Like I don't want to be the one person on the end, especially if there's like seats where I can move close to the middle. I want to get closer to the middle. So that's what everyone's thinking. So as they show up, they try to sit in the middle, but they don't want to fight anyone. So if you're actually assigned the middle seat, then you should get the middle seat. And then you need some type of, if there's nobody who's assigned the middle seat, you need some type of way to figure out who gets to sit closest to the middle. So what they have devised is these following rules. So it's actually a little clearer if we read the third one first. So, if we read the second one. We'll just start the first one. These rules only work all together. So this is a kind of a complicated thing where it's all these rules need to be true at all times together. So if no one is closer to the middle seat than you sit in the middle seat. So that means that if there's space to move into the middle, you're going to move there. But that also intersects with these other rules of for any given person sitting at a seat, no one who's closer to the middle seat than them has an assigned seat that is farther than them. So, for example, if I'm assigned the middle seat, or if I'm assigned one away from the middle seat, if I'm sitting at my one away from the middle seat, the person sitting in the middle has to be assigned the middle seat or the other side of the middle seat. There's no way that someone 5 seats away from the middle seat is going to be sitting closer than me, because you can imagine that in a real scenario. That'd be just unfair, right? If you're assigned 1 seat away from the middle seat, the person in the middle seat can't just be like 10 seats away, 20 seats away. That would be unfair. So your assigned seat is how you decide who gets to sit in the middle in case of disputes. So everyone's trying to sit as close to the middle as possible. So if there's a tie, so you can imagine there's always an odd, I believe I said there's always an odd number of seats just for simplicity's sake. If not, I guess it. Oh, I did? Okay. Yeah. So you can imagine like the middle seat is there, and then there's going to be a seat on the left side of it and the right side of it. So if there's a tie, if both those people show up, but there's no one in the middle seat, it'll always be the person on the right side of the seat or with the higher numbered seat that gets to sit in the middle. And now if you have a choice between 2 seats, you're always going to sit in the one closest to your assigned seat. So that means, how could you ever have a choice, right? Well, there could be cases where you get to sit in a seat that is 1 away from the middle seat, for example. That could be the left or right. So in that case where the person to the right gets to sit in the middle seat, that person now gets to sit in either the one to the left to it or the one to the right to it. But because they were assigned the one to the left of it, they're going to choose the left side. If they were assigned the right-sided seat, they're going to choose the right-side seat. And so with those 3 rules, you can devise exactly how the seat configuration is going to be. Okay, so let's start at who gets to sit in the middle seat, because you can actually just work from the middle outwards. So there's 2 ways to do this. You can create it without Zacho's seat, or you can create it with Zacho's seat. So I'm going to do it without Zacho's seat just so I can explain how it works a little better. So who gets to sit in the middle seat? So as the rules state, it's going to be the people who are the closest. So 5 and 7 out of this list are closest to the middle seat because they're both 1 away. There's no possible chance that anyone farther than 1 seat away is going to be sitting in that middle seat. So who gets to win it? Because there's a tie. 7 does, because he has the higher numbered assigned seat. So now 5 gets to sit in either seat 5 or seat 7, because those are both 1 seat away, and he will choose, or person number 5 will choose the one to the left because they were assigned a seat to the left of the middle seat. Now next, So we still have 1, 3, and 9 that still need to be seated. So who gets to sit at this other one? So who's the next closest? Is there anyone who are 2 seats away from the middle seat? So let's look. 6, 4. Is there 4 and 6 here? No. So now we look at people who are 3 seats away. 3 and 9 are both 3 seats away, and there's a seat here. So now there's a tie again. So 9 gets to take it because they have the higher numbered seat. And now 3 gets to sit at the next closest spot, and they have a choice. So they're gonna because they've been assigned a seat to the left, they're gonna go to the left. 3 gets to go here, and now because 1 is the last one, there's no competition. It gets to go here. Now what happens when we introduce 4 to this? So let's look at what happens. Let's go back to the middle. Are they closer than 7 to the middle? No. Are they closer than 1? Are they 1 seat away? No. Are they 2 seats away? Yes. So if we actually look at who's in these 1 seat away seats, because remember, I can't seat 4 at any of the 2 seat aways, because that would mean that 9 is seated closer to the middle than 4 is, even though 4 is assigned closer to the middle than 9 is. So that means 4 has to sit here, because, well, they're not closer than 5 to the middle, but they are closer to the middle than 9 is. So 4 gets to go here. And if we want to finish this out, that means we basically just shift it all down, where 9 gets to now sit here, because 9 and 3 are equal distances, but 1 is not as close as 3 and 9, and this would be the ending arrangement. But all we care about is where is 4 sitting, because that's Zach. So where is Zach's seat? At seat number 7.
Now it's easier to show it than to actually write it. That is a pretty tricky one.
Yeah, like do you have any stabs at how you might go about solving it?
Well, one thing I was thinking is sort of like, I might have a system where it would be like recursive, and it would keep on recursing until there was no more decision to be made. And then I would move on to the next, adding the next person to the theater. Like, I would go in order. I know you were saying that the order doesn't matter, but I just think for me, I would go in order like we did in that example.
Yeah. Yeah, like what Abram's talking about, because we were talking about this earlier too, is that you could do it one by one, where you could imagine, first let me look at the case where 1 is sitting there. Now let me introduce 3. Now let me introduce 5. Now let me introduce 7. Now let me introduce 9. And then 4. Andrea, do you have any thoughts on this question of like how you might, if you ran into this at a programming contest, how might you try to solve it?
Yes, I will also approach it one by one.
Yeah. Otherwise, it would be so difficult. That like to actually figure out a method to just take in a bunch and then sort it out. That would be pretty tricky to not do it one by one.
Yeah.
Well, honestly, I would kind of do it similar to how I was explaining it, because if you look at rule number 2, it gives you a lot to work off of, because it says obviously I made the question, so I'm probably going to know the solution the best, but any given person sitting at a seat, whoever's closer to the middle seat than them can't be assigned farther away than them, right? So that means you can start at the middle. Instead of just like trying to start by inserting people, you can look at the entire list with Zach included, so you don't have to make an insertion at the end, and look and say, who gets the middle here? Then you move out. Who gets the 1 minus? Who gets 1 close to the middle? Who gets 2 close to the middle? Who gets 3 close to the middle? And then you can pretty much do it in ON time. That's how,
and
or
you
ON
could even
divided by 2
stop
times.
once you get to the target. Like once you get to Zacho's number, you could just stop there.
Exactly, and that's a little bit of dynamic programming where you can halt the execution earlier to increase the speed time. Like, because like I was saying when I was explaining it, when as soon as we found the seat for 4, we didn't have to worry about shifting everyone else because we found Zacho's seat. But yeah, personally that's how I would solve it, is because we know that it doesn't matter the order that they're inputted in. We can look at it as a whole and just say, out of this list, who gets the middle seat? Out of this list, who gets the next seat? Who gets the next seat? Who gets the next seat? Until we reach that.
Well, I just want to say, generally, when it comes to dynamic programming, like, I'm going to end this program early because most of the time, Zacho will be sitting somewhere near the middle. They're always going to give you a case where Zacho is sitting in the least convenient spot.
Yeah.
You know?
So it'll make you always in at the very end, so you have to run the whole program
you need to always
for at least one case.
Yeah, exactly. If you can think of the worst case for your algorithm, they're definitely going to test on that.
Yeah.
So that's a big factor. Yeah. Okay. Well, that's all the questions that that we have in the problem set, let's just close off by we do have a bit of a fun question to ask because this is I know it's already February, but because this is the first of the year, we're asking what are your programming New Year's resolutions. So it has to be something related to programming that you're going to start doing in the new year. Adrian, do you want to start?
Okay. Honestly, I would say I want to work on optimal solutions a little more, because sometimes the solutions I think of tend to be like n squared, and usually in competitive programming n squared is unusable. There are rare questions where it is usable, but usually if you come up with an n squared solution, you're just going to end up with the time limit exceeded, and in a timed contest you could waste a lot of time on that. So I want to work on skipping that immediate like knee-jerk reaction to thinking I can brute force this, and try to think of a more elegant solution. What about you, Abram?
Andrea, do you have any New Year's resolution for this?
Yeah, mine was very simple. Like I would want to start committing to doing lit code problems like daily. Yeah. So far, like I am just going through the easy ones, and hopefully will challenge one of those hard ones soon.
Yeah, that's good. That's perfect. Yeah. Lit code is definitely great. I'd say my resolution is I would like to start reading questions better. Because I feel like I always misread questions, and then I end up writing something that works for a different question. You know? And then I submit it as like wrong answer. What's wrong? But then that I find is really annoying. I never read things all the way through. It's just so difficult to get through these questions to read through
honestly,
them.
I want to change my resolution to that because I have that same issue.
Yeah.
And sometimes sometimes simple things can really change like an entire question where it, for example, like maybe in this question, if I'm saying just Zach's position instead of saying like what's the expected complete like configuration after adding Zach, you know, sometimes those little specifications, or it's like the amount of times you do something versus like the end result. Like sometimes you're so focused on trying to figure out, man, how do I like in an optimal solution like figure out what the end result is, but really they're just asking like how many times did you loop to do it, so you actually don't even need to loop. You can sometimes you can do simple calculations like in remaining remainders. You might be thinking, oh, I have to like do a for loop and keep subtracting, but it's like, no, you just need to know how many times you do it. You just need to do a simple math arithmetic operation. But sometimes reading the question is really important.
That will be the first, like the very, if a person is about to start an ICPC question, for example, and they are seeing a question for the first time, they say they should take as much liberty as they could with just understanding the question before jumping to the sentence.
Totally, you're so much better off reading it twice.
And not just that, before you even start thinking of how to solve it, read the input and output first, because just that little line of what to output can completely change how to solve the question.
Yeah, totally. We'll definitely have another podcast probably in about 2 or 3 weeks as we get closer to some of these big events. We get closer to Google. Actually, Adrian, do you want to talk about some of the events that are just in the near future to close us off?
Yeah, so ICPC is coming up, I think, let me check, February 26th, I believe. Yeah, February 26th. Google hash code is 2 days before February 24th. You can, if you need help registering for either of those, just message somebody or post in general chat. We'll help you out for sure. The weekend before that, on the 19th, we're going to be having a little practice tournament for anyone who's participating in ICPC. We're going to be using Caddis, which is the platform which you'll be using in the contest, and we'll be doing the similar type of questions with similar difficulty to get everyone used to using the platform, the type of questions they are, and just general competitive programming practice. So if you're interested in that as well, make sure to send us a message. And yeah, those are all the stuff we have coming up.
Yeah.
Awesome.
Oh yeah. Dins, I have like a platform-specific question for you. Like, why Caddis?
Well, that's just what they use at ICPC. So because it's ICPC prep, like we want to make it as close to ICPC as possible.
Gotcha. And so that the input format will be similar to what
exactly. Yeah.
ICPC. Gotcha.
I will say even leak code, code forces, it's all pretty similar, to be honest.
Yeah.
If you practice leak code, you're going to be having the same advantage as other places. But Caddis is what we use at ICPC. Well, that's great. If you're still watching this podcast up to this point, that means you are in the top 5% of our fans, and we appreciate that very much. Make sure you subscribe. Make sure you like. Let's get this.
So that means you're my mom, Abram's mom. Top 5% of our fans that stuck out this far. Yeah.
All right. Well, we'll see you in a few weeks.
Bye.
Yeah.
Bye.
Yeah. Bye.